Here's a solution comparing the answers to number 5 and number 6 from the section 3.1 homework. If you remember, the chain rule for exponential function says that if we take the derivative of e to any power, doesn't matter what's in the box, that derivative will be e to the same power, so it's exactly the same thing you started with, but then times the derivative of what was inside that box. So for example, when we want to take the derivative of 1/7 e to the minus 3x, the 1/7 is a constant multiplier, so we just leave that where it is. Then we're taking the derivative of e to the minus 3x, and so we think of the minus 3x as being in the box, so that gives us e to the minus 3x, in other words, exactly the same e to the box that we had, times the derivative of what's in the box. The derivative of minus 3x is just minus 3. So this will be 1/7 e to the minus 3x times minus 3. Now, what happens a lot with the chain rule is that you have something stuck out in the front of the problem, and the chain rule sticks something on the back of the problem. And so often you can simplify this by combining these two things. Happens very often with the chain rule. And so since that's just arithmetic, 1/7 times negative 3, it makes sense to do. If it were something complicated, we might just not bother. But that is just simplifying arithmetic. So minus 3/7 e to the minus 3x is the answer to the derivative. Now let's compare that to what happens in problem number 6. In problem number 6, again, I'll remind you that the derivative of e to any power is just e to that same power times the derivative of whatever's in that box. So again, we have a number in front, just like we did before. It's an uglier number, but it's still just a number. So I leave that number alone. Constant multiplier, I leave where it is. Now I'm going to take the derivative of e to the x to the 9th. So that's a funny looking thing, but all that means is I'm using e to a power, e to the box, where the box is equal to that. So these two things match up exactly, e to something, e to something. So the box has an x to the 9th in it. And so the chain rule says that's e to the same thing, so nothing changes what's in the box in this first part. It's just exactly the same problem you had to start with, and then times the derivative of what's in the box. And so now I have to do that problem. Before, I had a derivative here that was the derivative of, what was it, negative 3x, so that was easy to do. This is the derivative of x to the 9th, so it's a different derivative rule altogether, but it's not hard. So I'll have equals 19/14 e to the x to the 9th times the derivative of x to the 9th is 9x to the 8th. So again, I can combine this guy and this guy. This can be moved over there and multiplied. So I can do 19/14 times 9x to the 8th and combine all that and then have that times that if I wanted to. That seems like it's a little more complicated, so maybe you decide not to. But if you do want to do it, you're going to have 9 times 19, which is 171 over 14, x to the 8th times e to the x to the 9th. So again, for purposes of an exam or something, this is perfectly fine. There's nothing wrong with that as an answer. But if the computer wants you to simplify that, all it really wants you to do is combine that and that. And the worst case is you might have to get a calculator out to do 9 times 19. And then you have 9x to the 8th times 19/14, which is 171/14 x to the 8th.